Okay, we're going to talk about a unit vector. So let's say, for example, I give you a vector. Let's do 2, -5. If you're given a vector with those components, so let's call this vector v. This is going to be my horizontal component, so that means I'm going right 2, and a vertical component means I'm going down 5. So if I was to graph this would be 1, 2, 1, 2, 3, 4, 5. So it would be something like that. Okay, so if I was trying to find the unit vector, what that means is I have to figure out this magnitude right here is a big number. I need to make it be equal to 1. So I need to find a vector that's going in the exact same direction but has a magnitude of 1. So what I'm going to do is I have to find the magnitude first of this vector. So I have to go 2 squared plus 5 squared, or -5 squared. And then that's going to get me 4 plus 25, which gets me the square root of 29. I can't simplify square root 29 any further, so I'm going to leave it at that. So that tells me this whole thing right here, from start to finish right here, has a length of square root 29. Instead of square root 29, which is a decimal of, it is 5.38. So I need to make that equal 1. So what I'm going to do is anything divided by itself is 1, right? So what I'm going to do is I'm going to divide these by that square root 29, because these right here get me this magnitude. So this right here tells me I'm going right 2 down 5. It's getting me this angle that I'm going that way. So now what I need to do is I need to go ahead and just simplify this out. Remember, I can't have a square root in the bottom. It has to be up top. So now I'm going to have 2 square root 29 over 29 times -5 square root 29 over 29. And that's because right here, instead of leaving it like this, I multiplied all 4 terms by square root 29. So I get 2 square root 29, -5 square root 29, and square root 29 times square root 29 equals 29. And that's because I can't have a square root in the bottom. So this right here is my unit vector. That's telling me that if I was going to go 2 square root 29 over 29, which that number, if I was to go ahead and get that as not a decimal, or not an exact thing like that and make it as a decimal, that's telling me I'm going 0.37 to the right, for example. 0.37, that's a tiny, tiny number. And then I've got -5 square root 29 divided by 29, and if I do that as, instead of an exact number, I do that as a decimal, that's going to be -0.93. So that means that this side right here would be 0.37, and I'd be going 0.93 here. If I do the Pythagorean theorem, I'm going to end up getting 1. That's the idea. So let me check that. And I'm going to use the exact numbers, but I'm going to use these right here because they're way easier to put in. What I mean is I'm going to use the equation to find the magnitude, which is the Pythagorean theorem, really. So I'm going to go 2 over square root 29 squared plus -5 over square root 29 squared. Got that. So now I'm going to go ahead and simplify this out. Well, 2 squared is 4. Square root 29 squared is 29. -5 squared is 25. Square root 29 is, or squared is 29. All right, so now I have 4 over 29 plus 25 over 29. Well, since they're fractions that I'm adding together, they have a common denominator, so I just combine the top 2. So that gets me 29 over 29, which equals the square root of 1, which is 1. So I do, in fact, have a magnitude of 1. So this right here, this big, ugly looking component form, that is my final answer. Now, I don't have to check it like I did down here. I don't have to do that, but it's just a good idea because that way you know for sure you have a correct answer. it's easier to use these numbers when putting it into the Pythagorean theorem right here versus using this. Could you imagine having to do 2 square root 29 over 29 squared just to do this part? Using these numbers are easier. Okay, so let's try another one. Just kind of make sure we've got the idea down. So if I give you the vector of, let's do 8, negative 20. This one gives us a couple of ugly things to try and deal with so you can kind of see all of it. Okay, so let's figure out the magnitude. So I've got 8 squared plus negative 20 squared. So that's going to get me 64 plus 400, which is 464. So that means I have to look and see if I can simplify the square root of 464. So that means I'm sitting there and I'm dividing by all the perfect squares that I can think of that are smaller than 464. This one kind of stinks because if you started big and work down all the way to small, well, you'd get all the way down to square root 16 and square root 29. So your final answer for this one, for magnitude, is 4 square root 29. So that means that the hypotenuse of the triangle that this creates is 4 square root 29, which as a decimal is 21.54. So it's pretty big. So I need to shrink that down to just 1. So instead of having this as the magnitude, I need it to be 1. So what I'm going to do then is I'm going to go 8 over 4 square root 29 and negative 20 over 4 square root 29. Now, right here, it's kind of something you need to catch, and not everybody sees it right away, but you need to notice that you can reduce. So if I can reduce these right here, 8 divided by 4 is 2, and I have square root 29 there, and negative 20 divided by 4 is negative 5 over square root 29. So now that looks a lot prettier and like something that I could, in fact, put back into the formula to find the magnitude of the Pythagorean theorem and make it nice and easy. But let me go ahead and finish and get my answer, then I'm going to go back and check it. So my answer here, if I multiply by square root 29 to all of these right here, I get 2 square root 29 over 29 and negative 5 square root 29 over 29. If I didn't notice that up here that I could reduce that, then I would have to multiply this by square root 29, this by square root 29, this by square root 29, this by square root 29. And I would end up on the bottom. These two would simplify right here to just 29, but I would still have 4 times 29. And then I would have to notice that I could reduce there. And that's a much bigger number, and I'm less likely to notice that. So it's easier to reduce as early as you can. So this right here should be my unit vector. Let me check it. I'm going to put it into the Pythagorean theorem, or the unit vector formula, or not unit vector, magnitude formula. I'm going to use these numbers though because these are easier to put into that than this. So that means I'm going to have 2 over square root 29 squared plus negative 5 over square root 29 squared. So 2 squared is 4, square root 29 squared is 29, negative 5 squared is 25, square root 29 squared is 29. Once I add these all together, I'm going to get 29 over 29, which is going to simplify to square root 1, which is 1. So this right here is my final answer. Okay? You do not have to check it. Like I said, it's just a good idea. It's a good habit to get into so that you make sure that you have the right answer. All right.